All right, so in this one we're going to be talking about inverses. So if you want to go ahead and do the warm-up and solve here. Okay. Number one, pause the video and go ahead and do it. Okay, so if I add 5, divide by 2, I get x is equal to 51. Okay, number 2, I have 1/3 x plus 40 is equal to 280, so I'm going to subtract 40. And multiply by the reciprocal for this one. So x is equal to, okay, because really we're multiplying, so dividing by 1/3 is the same as multiplying by 3, so 240 times 3 is 720, okay, and then my last one here, let's see if I can do it up in here, so we can add 10, divide by -4, and we get 4. Okay, so we're going to go ahead and skip this getting started here. Okay, so it says Miguel is planning a trip to Turkey. Before he leaves, he wants to exchange his money to the Turkish lira, or lira, not really sure, the official currency of Turkey. The exchange rate at this time of his trip is 4 per $1 US. Complete the table values to show the currency conversion for US dollars to Turkish. So it is 1 to 4, so that means I should be getting bigger. So what I need to do is multiply all these guys times 4. Okay, so go ahead and type those in your calculator. I'm going to pause the video and crank it out real quick. So it should look like that. It says write an equation to represent the amount of lira in terms of the number of US dollars. Okay, so I was multiplying 4 times my US dollars each time. So if I say my X is my US dollars, that would get me my lira, which is going to be my Y. Okay, suppose at the end of this trip, Miguel needs to convert any remaining lira to dollars. The situation is the inverse, the opposite direction of the original situation. What are the independent and dependent quantities of the inverse of the problem situation? How do these quantities compare to the quantities in question 1? Okay, so in this one, the independent is going to be the lira. Okay, and then dependent is going to be the US dollars, because in this situation, my US dollars are going to be affected by how much lira I have. So let's say we're going to say our lira here and our US. Okay, my lira right now is going to be 400. We had 1,000, 1,600. 2,600, and then 4,000. So if we were going backwards, this is independent right now, and now my US dollars is depending on whatever that lira is, I'm going to be affected. So now I have to divide by 4 to get smaller back to my US dollars, because there's less US dollars than there is liras. So now I'm taking it backwards. Okay, so compare the tables in question 1 and 4. They should be opposites of each other. So my x's and y's are kind of the flip of each other. Use a table to write an equation for the inverse of the problem situation. How do I say divided by 4? So I could do x divided by 4, or in this situation I could say 1/4 x, where x is going to be my lira and y is going to be my US dollars. Okay, so recall that a function takes an input value, performs some operation or operations on this value, and creates an output value. That's how we get the line or a graph. The inverse of a function takes the output value, performs some operation on the value, and arrives back at the original function's input value. In other words, an inverse of a function undoes the function. So given a function f of x, that's my function notation, you can determine the inverse algebraically by following these steps. Step 1, replace the function f of x with another variable, generally y. Y is the easiest one to switch to. Switch the x and y variables in the equation, and then re-solve for y. So it says use function notation to represent the number of lira, f of x, in the terms of the number of US dollars, x. Then complete this step shown in the work example to represent the number of US dollars in terms of the number of lira. Compare the inverse to the equation you wrote in question 6. So my original was 4x. Okay, easiest thing to do is change that function notation to a y, and then it said flip x and y. Just like we flipped it on our table, we flip it in the equation. Well, now I still want y by itself, so how do I get rid of 4? I divide by 4. So I have x over 4 equals y, if I flipped it around here to put y in the front. Okay, and then my notation for inverse, if I send it back to this f of x, I can't say f of x because then it would mean the exact same thing from my original. So your notation is f to the negative 1 of x. Okay, and it's going to equal x over 4. All right, in the previous activity, you wrote the inverse of a function using algebra. Let's consider how to show the inverse of a function using its graph. So given a function f of x, you can determine the inverse of a function graphically by following these steps. Copy the coordinate plane and graph f of x in the line y equals x onto patty paper. Heavily trace the graph of f of x with a pencil, reflect the patty paper across the line y equals x, and rub the paper so that the image of the graph of the inverse appears. So it says, consider the graph of the function f of x equals 4x from the previous activity. Complete the steps in the worked example to graph the inverse using patty paper. Okay, we don't have patty paper. So what you're going to do is you're going to take this equation, y equals 4x, you're going to graph it along with 3 other ones. You're going to graph it with y equals x, which is going to be kind of our line of reflection here, and then you're going to graph it with its inverse. So you're going to graph all 3 of these at the exact same time. So to do that, you type this one in y1, you type this one in y2, and you type this one in y3. So it says compare the image you created in graph of the inverse. What do you notice about the image and the graph of the inverse? It should be a mirror over that y equals x line. What does this tell you about the graph of a function, its inverse? Anytime you graph something, its inverse will always mirror across y equals x. So you should see it kind of mirroring across that every single time, any type of graph that we do. It says for each function and a given point on the graph of the function, determine the corresponding point on the graph of the inverse of its function. So given that 3, 2 is a point on the graph of g of x, what is the corresponding point on the graph of the inverse of g of x? Flip the point. Given that negative 1, 0 is a point on the graph of h of x, what is the corresponding point? We flip it. Okay, given that AB is a point, we flip it. Okay, its inverse is always the flip to get that mirror across the y equals x. In this activity, you will determine the inverse of a function using multiple representations. For each given function, determine the inverse using its representations. Complete a table of values for the function and its inverse. You're going to sketch the graph on the coordinate plane. You're going to write the equation for the inverse and determine whether the function is 1-to-1 and explain your reasoning. So we need to know what 1-to-1 is. A function is a 1-to-1 function if both the function and its inverse are functions. So it needs to pass my vertical line test, which I'll talk about. Okay, so to find this, you can either plug this into your calculator and then look at your table to do this. So if I plug it in, I go to my y equals, I do 3x minus 6, I go straight to my table. Okay, I go to negative 2, his answer is negative 12, negative 1, negative 9, 0, negative 6, negative 3, and then 2 is 0. So if I graph them now, negative 2, negative 12, negative 1, negative 9, 0, negative 6, 1, negative 3, and 2, 0. So this is my line right now. Okay, I could keep it going if I wanted to. The inverse, we flip it, so now I've got negative 12, negative 9, negative 6, negative 3, and 0. So now I go left 12, up or down -2, which will be somewhere here. Left 9, down 1. Left 6, 0. Left 3, 1. And then 0, 2. Okay, so you can kind of see that they would mirror each other across that. Okay, so then if I needed to make that equation, find where it crosses my y-axis. It's a line, so y equals mx plus b. Crosses my y-axis at 1, 2. I got to get my slope, so it looks like I rise 1, run 3, and then we are increasing, so it's a positive 1/3. Okay? Okay, well, let's say you're bad at that. Let's go ahead and take my f of x and do it like we just learned. So change that to a y. We flip-flop x and y. Now we resolve. So x plus 6 is equal to 3y. When I divide by 3, I divide them all by 3. So I've got y equals x over 3 plus 2, which is the same as 1/3 x plus 2. Okay, so we got to answer the last question. Is it a function? Does it pass my vertical line test? So if I made trillions of vertical lines, it should only ever cross those lines at one point. If it crosses it multiple times, so like if I had a circle, that would not be a function because it would not pass my vertical line test because it crossed twice. Okay, so this one here, same thing, go to y equals, type in negative x plus 4. Go to your table. We're starting at -2, so 6, 5, 4, 3, 2. So -2, 6. -1, 5. 0, 4. 1, 3. 2, 2. We flip them, so 6, 5, 4, 3, 2. So I go 6. Let me change colors here. 6, -2. 5, -1. 4, 0. 3, 1. 2, 2. Okay. So we're going to do it mathematically. So it was g of x. We're going to change it to y. Okay. Ooh, in my last problem, I should have labeled this new guy f to the -1 of x is equal to. Remember, we're going to practice writing that. That's my new function notation. Okay, so this, now we flip-flop our x and y. That's the only thing that moves. That's, okay. Subtract 4, so x minus 4 equals -y. Divide everything by -1. So I've got y equals -x plus 4. And then I use my new function notation. So f to the -1 of x equals -x plus 4. So that should be my new graph. It should, if I would have drawn my line a little straighter, it should have crossed at 4, okay, and then it would have gone down 1 over 1. Okay, my next one, y equals 2. Okay, it should be a straight line this way. All these little guys should be 2's when I type in y equals 2. So this one's going to be a straight line this way. Okay, this one's a little weird. How do I get this? If this is y equals 2, this one's actually going to be x equals 2. So my inverse function of this is actually x equals 2. Okay, so we get 2, 1, 0, 1, 2, because we're taking the absolute value. So -2, 2, -1, 1. Ooh, this passed my vertical line test. It is a function. This one does not pass my vertical line test. It is not a function. If I did a vertical line right on top of this, it would cross lots of times. Okay, so this would not be a one-to-one. Its inverse would not be a one-to-one function. Inverse, not 1, 2, 1. Okay, because it doesn't pass my vertical line test. Let's go back to this one. Okay, now we got to flip them. So 2, 1, 0, 1, 2. So let me change colors. 2, negative 2, 1, negative 1, 0, 0, 1, 1, 2, 2. Okay, my inverse is not going to work again. So inverse, not 1, 2, 1. If I did a vertical line test, it would not work. And his equation is actually kind of weird. So if I do y equals absolute value of x and I flip them, you can't undo an absolute value. Okay, so that's why this v is just turned sideways. So in that one, you just have to go based on your graph, because you can't undo this. Where you can undo an x squared with a squared root, you can't undo an absolute value. So it's a little bit weird. Okay, so it says Adam and Stacy are working on a homework assignment in which they must identify all functions that are one-to-one functions. Adam says that all linear functions are one-to-one functions, so they don't even need to look at the linear functions. Stacy disagrees and says that not all linear functions are one-to-one functions. Who is correct? Explain. Well, normally we think of linear functions, remember it's a line, going this way and this way. But we can also have a linear function go this way, which would not be one-to-one, because if I did my vertical line test, it would be bad. So that's still technically a line, it's just going up and down. So Stacy is correct in this one. Okay, it says, how can you determine whether an inverse exists given a linear function? Okay, it's the only linear functions for which an inverse won't exist are constant functions. For all other linear functions, an inverse should exist. So a constant function increasing by the same amounts, that straight up and down. It says, can a linear function and its inverse be the same function? Yes, the inverse of any function that is symmetric about the line y equals x will be equal to the function. For example, the function f of x equals x, the inverse is f of x equals x. Okay, also the function f of x equals negative x plus 1, and its inverse f of x, f to the negative 1 of x equals negative x plus 1. So the big one that you would assume is literally the one that you're reflecting over, and his inverse, since they're the exact same, the other one that works is the negative x plus 1. So we're going to skip the last one there.